right, today's notes are on graphing again. This time we are graphing quadratics in vertex form. So first thing is to remember what's vertex form. Well, you guys learned what vertex form is from the PowerPoint with all the vocabulary. And it looks like this: y equals a times x minus h squared plus k. And graphing in vertex form is actually a lot easier than graphing in standard form. And this is why. So we're going to do a little like remembering back to some old lessons. So remember, ... When we did all that shifting, remember when we did the parent function cheerleading and I said, you know, move to the left, move to the right, up, down, tall, skinny, whatever, reflect. So you're going to use that when you're graphing in vertex form. So remember that if your parent function is y equals x squared, it looks something like this. If I have y equals x squared and I add something outside, like let's say I add 3, what does that do to my function? Well, it moves it up 3 spaces, 1, 2, 3. Everything else stays the same. If I subtract, it moves it down. So this part plus 3 moves it up 3. If I subtract, it would have moved it down. Now let's think about inside the print. Well, let's write an example here. If I did x squared minus 3, 1, 2, 3, it would have moved it down 3 spaces. Down. Okay? Now let's think about inside the parentheses. So I'm still on my remember thing. If I'm inside the parentheses and I add, let's say I add 1, that does not move it to the right, it moves it to the left. Remember, it does the opposite of what you think. So it moves it to the left 1 space. If I'm inside the parentheses and I subtract, that actually moves it to the right 1 space. Okay, so outside, up and down is what you think. Adding's up, subtracting's down. Inside, it's the opposite. Adding's to the left and subtracting's to the right. Okay? So let's apply that to this function. Y equals x minus 1 squared plus 3. Well, I know it's just like my regular quadratic, except now instead of my vertex being at the origin, it's been moved to the right 1 space and up 3. There's my vertex. So step 1 is plot vertex. Your vertex in this case is 1, 3 because you moved to the right 1 and up 3. Now I need to know where the rest of the points on my graph are going to go. So second thing, just like before, we need to plot another point. You can pick any x value except for the x value from your point. I'm going to pick an x value of, I don't know, let's do 2. Okay, notice 2 is not the same as the x from my point, so I can use, or from my vertex, so I can use it. So y equals 2 minus 1 squared plus 3. 2 minus 1 is 1 squared plus 3. So that's 1 plus 3, which is 4. So my other point is 2, 4. And I'm going to draw in my axis of symmetry here through my vertex. Plot my other point. 1, 2, 1, 2, 3, 4. And last step, step 3, is to reflect. So I'm 1 point away from the vertex on the right. I'm going to go 1 point on the left, or 1 space to the left. So when I reflect, I get the point 0, 4, which also happens to be my y-intercept. I'm going to connect those, and there's my graph. So again, first plot the vertex. You get the vertex from thinking about your shifts. To the right 1, up 3. Second, plot another point. I picked x equals 2. I could do that because 2 is not the same as the x for my vertex. I substituted in. I got a y value of 4. So my other point was 2, 4. So here was my vertex. Here is my other point. And then I reflected it, third step, to get my third point, and I connected. Okay? And that's it. Let's come back here for a second. So we talked about shifting left and right and up and down. Well, let's look at another example here. And this will be our last example. I'm going to go -3 times x plus 2 squared minus 1. So first step is to find my vertex. Well, my vertex is moved to the left 2, so -2, and down 1, -1. It's always going to be the opposite of this sign in the middle for your x value. There's my vertex. I'm going to plot it, -2, -1. I'm going to draw my axis of symmetry. And now, step 2 is to find another point. Plot another point. Here, let's pick 0 for our x value. X equals 0, y equals -3 times 0 plus 2 squared minus 1. -3 times 0 plus 2 is 2. 2 squared is 4. So we get -12 minus 1, which is -13. So my other point is 0, -13. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Way down here. Now step 3 is to reflect. So I'm 2 spaces away on the right. I need to go 2 spaces on the left. So my reflected point is -4, -13. I'm going to connect. And there's my graph. So remember, step 1, find the vertex. Step 2, plot another point. Step 3, reflect. This is our vertex. Here's our other point. And then we reflected it. Done. So conclusion. In vertex form, y equals a times x minus h squared plus k. What is our vertex? Well, the vertex always ends up being h, k. And there's one restriction on a. We say that a cannot equal 0. If a equaled 0, it would cancel out our squared, and we wouldn't have a quadratic anymore. Remember that the squared is the part that makes it a quadratic. Okay? Other things to think about, we talked about this already in the other PowerPoint. If this value here, our a value, is negative, remember that reflects it down. It should be a frowny face. If it's positive, it keeps it facing up. So if a is negative, we end up with a frowny face. If a is positive, we end up with a happy face. Okay, these are the same things that we discussed a couple units ago when we talked about reflecting. So remember, if this is positive, it keeps it facing up. If it's negative, it reflects it down. Also, one other thing to think about that we discussed. If a is bigger than 1, remember it made our graph tall and skinny. This is just a check. If a is between 0 and 1, it made our graph short and fat in comparison to the parent function. Okay, remember the parent function here is y equals x squared. So there you go. This should help you graph. Remembering your shifts up and down, left and right will help you understand where the vertex comes from. Remembering that if you have a positive a value, it's a happy face, like here. If you have a negative a value, it's a frowny face, like here. Also, this hasn't been stretched at all or compressed. It's not taller and skinnier or shorter and fatter because a is just 1. Here, it's taller and skinnier because this is the 3, without thinking about the negative, is bigger than 1.